Hey guys, so today we're going to start some Chapter 9 notes. We're going to actually start with some information from Chapter 6. So the first thing we're going to talk about is the definition of a polygon. And a polygon is a closed figure with straight sides. Alright, so there are a couple of different ways we can categorize polygons. One way to categorize them is convex versus concave. Okay, so let's take a look at that. Convex means that all the diagonals, if we drew in the diagonals of a polygon, all the diagonals stay within the polygon. So all diags stay within polygon. Versus concave polygons, it's actually possible to draw in diagonals that are outside of the polygon. So it's possible to draw a diagonal outside the polygon. And I'll put poly for polygon. So the easiest way to remember this is to take a look at the word concave. Concave has the word cave in it, and that's really the easiest way to remember it, is that concave polygons you can kind of draw in a cave, and we'll look at some examples, versus convex, there are no caves when you draw in the diagonals. All the diagonals are within inside the polygon. So another way we can talk about polygons is talking about if they are regular or not regular. So if we talk about regular, we don't just mean like a normal polygon, we actually specifically mean that all sides and all angles are congruent. So all sides and all angles are congruent. So regular polygon, all sides and all angles are congruent. Alrighty, so now what we're going to do, we're going to move on to some examples here, now that we have some definitions. And what we're going to do is try to figure out if these examples are polygons, and if it is, we'll talk about convex versus concave, if it's regular, and then what the name of the polygon will be. So let's start off with number 1 here. Remember, the definition for a polygon is a closed figure with straight sides. So if you take a look at this, the first question you're asking yourself is this a polygon? No, because of the curved side. So you would say no, and you could give yourself a little note, because there's a curved side. That's not going to work out. All right, so that one was easy. Let's work on number 2 now. If you look at number 2, the first thing you want to check, is it a polygon? So closed figure with straight sides. Yes, it's a closed figure with straight sides, so we're good. So you could say yes, it is a polygon. Now remember the next questions were, is it convex or concave? So if you start drawing in some diagonals and connecting points here, if you drew in this diagonal, if you drew in this diagonal, but if you drew in, let's say, these 2 connection points, you actually create a cave right here. So this is actually a concave polygon. Okay, so make yourself a note for that. And also we want to know, is it regular? Well, we don't know if all the angles and sides are congruent. It doesn't really look like it. So we'll say it's not regular. Or you could say irregular. And lastly, what's the name of this polygon? We're going to be talking about the different names, but we'll chat about it really quickly here. Let's just for right now write down how many sides it has. So I'll count it with the highlighter here. 1, 2, 3, 4, 5, 6, 7. So it has 7 sides. Maybe you know the name, maybe you don't, but we will come back to that. All right, so let's do a couple more of these examples. Number 3, first question again, is it a polygon? Yes, it's a polygon because it is a closed figure with straight sides, and maybe you've seen this before. So yes, okay, it's a polygon. You want to look, are all the sides and angles congruent? When we're not given any information about it, if you notice the sides and angles aren't marked congruent, we don't really know anything, so we're going to say it's not regular. Okay, and kind of switched around those steps. Our other question, remember, is it convex or concave? Remember, concave means with caves. It has caves in it if you draw in the diagonals. For this, if you draw in some diagonals here, if you trace in any connecting points, we're never going to have a diagonal that's outside of the polygon, so this is going to be a convex polygon. Okay, and lastly, you want to know, what is this called? How many sides does it have? Again, just count up the sides really quick. 1, 2, 3, 4, 5. This is a 5-sided figure. Might be more familiar with this, maybe pentagon, if you've heard that. So that's a pentagon, and again, we'll come back and talk about other names as we go here. Okay, we're going to try a couple more. Let's go to number 4. Again, your first question, is it a polygon or not? We would look at, is it a closed figure with straight sides? Yes, it is. Okay, your next question, is it regular? Well, we don't know if any sides or angles are congruent, so we'll say it's not regular. Okay, convex or concave? Remember, you want to draw on some diagonals. The first diagonal I'm going to draw in here will give it away. It creates this cave right here when I draw on a diagonal, so it's actually going to be a concave polygon. And lastly, you want to count up the sides really quick to see what type of polygon this is going to be. 1, 2, 3, 4, 5, 6, 7, 8. It has 8 sides. And again, we'll come back and label that as we go here. You may already know the name. All right, so let's take a look at number 5. This is a little different than some of the ones we've seen. The first thing we want to talk about is it a closed figure with straight sides, right? Is it a polygon? It's actually not a polygon. The reason for this, kind of a way to summarize it, is that you can't have more than one intersection point. If you guys see these points right here, okay, you cannot have that. So more than one intersection point. It just doesn't work out for what our definition of a polygon is. Okay, let's try one more together. If we take a look here, this is, again, we're checking, is it a closed figure with straight sides? Yes, this is a polygon. Okay, your next step, remember, is to look if it is convex or concave. Draw on some diagonals, you know, just test it out. You can kind of get an idea as we go here. Oops, that was not a good diagonal. There we go. This is going to be convex because there are no caves. Okay, all the diagonals are within. Look at the sides. It's almost regular, if you guys notice, but if you notice these two sides here, those are different than, you know, the rest of these guys. So this is not going to be regular. So not regular. All right, last thing is what type of polygon would we call this? If you really quick check the sides here, 1, 2, 3, 4, 5, 6, 7. And again, maybe you know that name, maybe you don't. It's 7 sides, and we will come back to talk about that after we learn some names. All right, guys, so you're going to finish up the last few of those problems where you're checking out if it's convex, concave. You'll figure those out with your teacher tomorrow in class. So if you guys would turn to the next page, we're going to talk about some names of polygons. Okay, so if we zoom in here, you might want to pause the video and see how many of these you could do for yourself. I bet there's a few at least. I know we've had full units on. So, for example, 3-sided polygon would be called a triangle. And I'll just go through these here, and you feel free to pause the video and see what you can do yourself. So 4-sided figure, another unit we've had, quadrilaterals. 5-sided figure, some of these are kind of new. Maybe we talked about it earlier though, a pentagon. 6-sided figure is a hexagon. Okay, a 7-sided figure is called a heptagon. Eight-sided figure, octagon. Think of an octopus has 8 legs. It's an easy way to remember it. 9-sided figure is called a nonagon. Okay, 10, decagon. 11 is called a hendecagon. Okay, and you see we have a lot more left. I mean, honestly, there's infinite, but we're going to be able to kind of generalize these as we go. So just to finish here, we're also going to talk about 12-sided. That would be a dodecagon. But after 12, we're just going to, there are specific names, we're just going to generalize them. So, for example, 13-sided figure we'll call a 13gon, 14-sided figure we'll call a 14gon, etc., etc. I think you can fill out the rest there if you want. And so for any n-sided polygon, 20 sides, 50 sides, 100 sides, we're going to call it an n-gon, a 20-gon, a 30-gon, etc. All right, so those are the names. If you guys want to quickly flip back then, you should be able to name the two shapes that we didn't name. I believe it was number 2 and number 4 and 6. So really quick, flip back. So if you're looking at that page, we had number 2 had 7 sides. So maybe now you can figure that out. That's going to be a heptagon. So jot that down. Number 3 was a pentagon. It had 5 sides. Number 4 had 8 sides. Maybe you knew that one. That was an octagon. And number 6 was the other one we didn't have, and that was 7-sided, therefore a heptagon. All right, so if we continue then, once you're ready, press play and continue onto this page. The last thing we're going to talk about is some different formulas for finding things about polygons. So we're going to be using these a lot. It's going to be worth memorizing, and you'll start to get them as we go here. So here are your kind of 4 important formulas for right now. So if I gave you any polygon, you could find the sum of interior angles. We're going to talk about one interior angle, sum of exterior, and one exterior. So the sum of interior angles, it's going to be n minus 2 times 180. Okay, n, remember, is the number of sides. Okay, to find the measure of one interior angle, you're going to take basically the sum, which is n minus 2 times 180. You're going to divide that by n, the number of sides. The sum of exterior angles is always going to be 360, so it's an easy question to answer. And the measure of one exterior angle is going to be the sum, which is 360, divided by n. All right, so once you have these 3 down, these are super important here. There's 4 equations. Okay, we're going to try some of this. We'll try with a couple of these problems, and then you guys can try a few more tomorrow. So if you guys want to zoom in here to number 1, we have a 15-gon. I'll actually leave the equations up for now. There we go. Okay, a 15-gon. And so n is equal to 15. And all you're really going to do is just plug and chug here. So we want to find each of these. So let's first find A, which is the sum of interior angles. So I've got 15 minus 2 times 180. Okay, if you want to plug that in a calculator, you get 15 minus 2 times 180. You're going to get 2340. All right, so for part B, we have the measure of one interior angle, so n minus 2 times 180 over n. Okay, remember, that just really means the sum, which we just found. So 15 minus 2 times 180 divided by 15. We already know that the numerator, it's this guy, 2340 divided by 15, and we get 156. So each angle inside of a 15-gon, if you drew out the whole 15-gon, you know, this is not actually an accurate drawing, but something like this, that would be one interior angle would be 156 degrees. Okay, so then lastly here we have 2 more questions. It says, how about the sum of exterior angles of a 15-gon? Always 360. And finally, for part D here, it says, what is the measure of one exterior angle? You take 360 divided by 15, and we get 24 degrees. Okay, if you guys forgot what exterior angles would be, that would be if I extended this side, it would be this angle right here, the angle on the outside. So if you took this angle, it'd be this angle right there, the exterior angle. All right, so now we're going to try a pentagon. We'll try one more together, and then you guys will have some to work on tomorrow. Okay, so a pentagon, again, I'll leave the equations up. So for a pentagon, we have part A, we figure out the sum of interior angles. N for a pentagon would be 5. So 5 minus 2 times 180 would be 3 times 180, which is 540. Part B, this measure of one interior angle. We're going to take the sum and divide it by n, right? So we have 5 minus 2 times 180, which is 540, divided by 5. Okay? And remember, this is the same thing as saying 5 minus 2 times 180 divided by 5, and that is equal to 108 degrees. So each interior angle is 108. Part C, sum of exterior, always 360. And finally, part D gives us 360 divided by n, which in this case is 5, and we get each exterior angle is equal to 72. Hopefully you're noticing here, guys, something really important to connect. This interior and exterior, hopefully you notice something special here, is that they are linear pairs, right? They add up to 180, they're supplementary. Alrighty guys, so with that being said, you are all set here. Hopefully you have all those notes down, make sure you do. Tomorrow we'll be trying number 3, 4, and 5, and we will be practicing this a little bit more in class.